Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see the overview of today's session. Today we will be discussing about double linked list and its operations. In the previous video, you can refer what is a double linked list and what are its structures. In this session, we will be discussing about double linked list and what are the different operations we are going to perform under double linked list. Let us see. Here, what is a list ADT? We already know ADT is nothing but it is a collection of data and operations to be performed. In double linked list, what are the different operations we can perform? Let us see. Here you know that what is data is nothing but you are going to have the collection of elements to be represented in terms of a double linked list. And what different operations we can perform here are. One is creation, then insertion, followed by deletion, and last we are going to display or traversal, right. Creating is nothing but we are going to create a double linked list with n number of nodes, right. And insertion means again, as we have seen in the single linked list, we have seen 4 different types of insertions we can perform. In the same way, here in the double linked list also we can perform 4 different types of insertion. That one we will see in the next video, okay. And followed by deletion. Deletion also we come across 3 different deletions we can perform, different positions. In different positions we can delete the nodes. That one we will be discussing under deletion part. And while seeing about the traversal, in the single linked list we have seen the traversal only in the forward direction, right. And here in this we are going to see the backward direction also. That means in the reverse order also we can traverse and we can display the elements of the list. Let us see how we are going to perform the creation. First, we will see creating a double linked list for 3 nodes, and that will be generalized later. Step 1. First thing what we require is we need to declare a node structure. For a single linked list also we have seen, first we need to have the node structure to be declared. How we are going to give that? This is same as by using the struct node keyword followed by the struct name. We are going to specify the node structure. And here in the double linked list, we are going to have 3 parts for the node. One is data, and another one is the previous address, and the other one is the next address where we are going to store. In the same way, the structure of the node also going to be represented in the same way. Let us see. This is the data part. This will store the next address. This will store the previous address. This is how the node structure will be. Now, we will declare few of the pointer variables where we are going to use in creating the double linked list. That is, head equal to null. Pointer head equal to null represents the list is empty. The last pointer represents the end of the list, and end represents every time we are going to create a new node. For that purpose, we are going to use the end pointer, and temporary pointer variable where it is going to move in between the head and last. Why? Because we are not moving the head and last anyway, right? Any point of time we should not move head and last. Just we need to move between head and last by using the temporary pointer variable. For that purpose, we are going to use the temp pointer. This is how the node structure, already we have seen how the node structure is. Now, after having the node structure, the second step is we need to allocate the memory for a new node. For that, we are taking a pointer variable n. And how to allocate the memory dynamically? That can be done by using malloc function. By using malloc function, we are going to allocate the memory. You see, this is how where you are going to allocate the memory. You can refer regarding the malloc function where we have discussed in the single linked list. You can refer that video how this syntax is going to be written, right. Based on this, a memory block will be allocated with the name n, and we are going to read the data value, and next part is assigned to null, and the previous also assigned to null. Now you can see here, these are the steps what we have represented. Based on that, here you can see this is a node, memory is allocated for the node. The data part which we are going to read is 10, that is going to stored in the data part, and the previous n arrow previous equal to null. In the previous address we are going to store the null value, and in the next part we are going to store the null value, that is n arrow next equal to null. This is how a node is created. And then after creating a node, first we are going to check the first condition is head equal to null. If head equal to null means that is representing the list is empty. If the list is empty, whatever the node you have created, that becomes the head node as well as that becomes the last node. That means what we need to write here, this should become the head node and this should become the last node, and the name of this node already we have is n. Now we need to assign this n value to head as well as the last. That's why we are writing head equal to n and last equal to n, right. This is how the first condition is verified. Next again we are going to allocate a memory for the new node. Again we are calling the creation function. Based on that, again the memory is going to be allocated dynamically by using a malloc function. Now if the first condition whatever we have verified, head equal to null, right, these things are everything will be similar. Again we are going to allocate the memory, reading the data part as 20, and next and previous values are assigned to null, right. Now based on this, observe, this is how the node will be created, and now it will be checking for the next condition. That means first time head is equal to null. The first condition which we have verified is head equal to null. Now when I am going to create a new node for the second time, now this condition will be failed. Why? Because head is pointing to 1000 now. Because of that, this is not null. Now whatever the new node I am creating, that will be added to the new node which is already existing for the first node. Suppose I have already the first node. Now whatever the new node I am creating, that will be making as a new connection. Based on that, it will be connected as a next node, right. For that we are going to write else part. This is a new node which we have created. This is 2000 and this is head and this is last, and the address of this is 1000, right. And initially you know that this is null and this is 10, and here still it is null only. Still we didn't make any connection over here. Now how to make the connection for this? First we need to make this connection, right, and this is nothing but we should not move the head value. That's why we are going to make the connection based on last, that is last arrow next equal to n. That means first we are going to store the address of 2000 here, okay. That connection is done. Based on this step we are going to make the connection. Next, and at the same time we need to make the previous connection also. This part is called previous, right. So that n arrow previous, n is the name of the node and this location is previous, n arrow previous equal to, we are going to connect with last, right. We are going to connect with last, n arrow previous equal to last. We should not give it as head. If keep on adding the new nodes, then it will every time you don't find the head value. That's why we need to connect it to last, right. At the same time, when I am going to add a new node here, this should become the last node. This will not be the first node or something. This should become the last node. That's why we are going to assign last equal to n. Now you can see the diagrammatic representation for this, both of this. This is the first node and this is the last node, how we have made the connections and how we are going to represent all these steps. Now in the similar way, we are going to create the third node also. The node is created, right? This is the node which it is created. Now in the similar fashion, we are going to check for the condition else part. It will go for the else part and it makes a connection over here. Now this is your last node, right? As we have seen in the previous step, this is the last node. Now we need to make the connection for this. This is nothing but this connection when you are going to make last arrow next equal to n, that is one step. At the same time here when you are going to connect the previous, this is your n node, n arrow. What are the steps we are going to get? Last arrow next equal to n, this is one, and n arrow previous equal to last. At the same time this node becomes the last node. That means you need to write last equal to n. That is the else part is repeating when you are going to add new nodes to the end of the list. This is the creation part, and let us see what is how you are going to write the code for it. This is a create function where you are going to allocate the memory, read the data part, and next and previous are assigned to null values. In the first case, if the head is null, that means if the list is empty for the first time, at that case we are going to check head equal to null, and whatever the node we have created, that becomes the head node and that becomes the last node. That's why we are assigning head equal to n and last equal to n. Next, for the second time, this is the first node which we have created. If I am going to create a next node, again I am going to call the same function create. In that case, this condition is going to fail. Why? Because the head is assigned with some address. Because of that, this condition is going to fail. Then it will go for the else part, right? And after that, this will become the new node, and we have seen how you need to make the connections. First, this last has to be connected to the new node which we have created, that is last arrow next equal to n. And we need to do the previous connection also. That means here we are going to store the address of 1000, and here we need to store the address of 2000. This is done based on n arrow previous equal to last, and at the same time last equal to n. This becomes the last node and this is the head node. In this way we can perform the creation operation. Next, now we have created the nodes, right? Now we need to traverse through the list, and I want to display all the elements in the nodes which we have created. Now let us consider, I have created 3 nodes and we have made the connections of forward as well as the previous connections also, right? Now based on this, how you need to traverse through the list and display all the elements of your created node list in the double linked list, right? Let us see here what we are going to do. Here first we are going to assign temp equal to head. This is your temp value and this is the head value. Now we are going to make the connection. First step, temp equal to head. Now temp is pointing to 1000. Now we need to traverse through the list until you reach the null value, right? While temp not equal to null, yes. What is the temp value? 1000. First condition, 1000 not equal to null. This has to be traversed until it reaches the null value, right? Now, it is not the thing. Now it is, your temp is here. Temp is not equal to null, 1000 not equal to null. Now, you will be entering into the loop and you are going to print the temp arrow data value. Temp arrow data is nothing but the 10 value is going to be printed. 10 is printed. Now, after that, temp should be moved to the next location. Now, my temp is moving to the next location. Sorry. Temp is moving to the next location. Next is nothing but temp equal to temp arrow next is nothing but 2000. Now, temp is pointing to this location. Now, again check the condition, 2000 not equal to null. Yes, again the condition is true. So, that you are going to move, you are going to print temp equal to temp arrow data. That is, what is the temp arrow data is nothing but 20. 20 is going to be printed. Now, temp should be moved to the next location. Now, temp is moving to the next location. Next location it is going to move. 1 minute. Here it is going to move, right? Now, Again you are going to check the condition. Temp now is 3000, 3000 not equal to null. Again the condition is true, so that it is going to print the temp arrow data value, that is nothing but 30 will be printed, right. Now temp is moving to the next location, that is nothing but it is pointing to null value, right. Now it reaches the null value. Now it this loop is going to check null not equal to null. Here the condition fails. Now the loop is going to be terminated, right. Like this way we are going to print the elements of the double linked list in the forward direction in this fashion. And while coming to the double linked list traversal based on backward direction, we can move. Now we have seen the forward direction, we will go back and we can print. That means in the reverse order we are going to print the elements. That means I want to print the elements 30, 20 and 10. In that case what we can do? But when you have seen in the single linked list, it is a big process where we have taken the array and then we are going to store that array elements into one temporary variable, and then we have used our array logic to print the elements in the reverse order. Once you can check, you can refer that video which I have already given, right. And now it is very simple in this double linked list to print the elements in the reverse order. Now let us see what we need to do. I need to print it from 30, right. That's why what we are going to do is, we are going to initialize our temp equal to last. Now temp starts at this position. Temp starts at this position. Now I need to move back, right, until again you could observe here in the head as well as in the last, head previous is null and the last next is null. This is the condition where it has to satisfy for the double linked list, right. So that until you reach the null value here, you need to traverse through the list. That's why you are going to write the same condition, that is temp not equal to null. Until that you are going to move backward, right. Now if the condition is true, we are going to enter into the loop and we are going to print the values. Here what is the temp value? Temp value is 3000. 3000 not equal to null. Yes, condition is true. You are going to print temp arrow data. What is your temp arrow data? Is 30. 30 is printed, right. Next, now you are moving temp equal to temp arrow previous. Previous means now from here to here it will move. That means temp arrow previous is nothing but 2000. Now temp will be moving to the next location. Now this is your temp value, right. Now again temp is going to be verified, that is 2000 not equal to null. Again the condition is true. Now you are going to print a temp arrow data will be printed. What is your temp arrow data? That is 20. This 20 will be printed. 20 is printed, right. After that, after printing 20, now temp should be moved to the previous location. Now previous location is nothing but 1000. It has to move to 1000. It has to move to 1000, right. 1 minute. 1000 it is. Now you could observe here, this is temp. Now 1000 not equal to null. Done. Yes, again the condition is true. It is going to print the temp arrow data value, that is 10 is printed. Now coming to temp equal to temp arrow previous. Now temp will be pointing to the null value, like this way. It will be moving to the null value. Now it is going to check the loop condition, null not equal to null. Now the condition fails. Now your loop will be terminated. And what are the elements that was displayed here? 30, 20 and 10. This is about double linked list traversal backward representation. Now in the summary, what we have seen in this session is we have seen about the double linked list and its operations. Under that we have seen how we are going to perform creation of double linked list for few nodes. Then we have seen about traversal or display. Traversal or display. In this also we come across two different types of displays we have seen. One is forward display and another one is backward display, right. We have discussed about the logic also. You can able to execute this program. Yes, this is about forward and backward display. You can able to execute the program. Thank you. If you have any doubts, please do comment in this comment section. Thank you.